Hey everyone, and welcome back to the channel. Imagine for a moment, gazing up at the night sky. What do you see? A familiar, comforting orb, our moon, a constant companion in Earth's journey through space. For billions of years, it has dictated our tides, inspired our poets, and illuminated our darkest nights. It's so ingrained in our perception of the cosmos that we rarely stop to consider. What if it wasn't alone? What if, instead of a solitary sentinel, two majestic spheres graced our heavens? This isn't just a whimsical thought experiment about a prettier night sky. The presence of a second moon would fundamentally rewrite the very fabric of our planet, from its geological pulse to the rhythm of life itself. A delicate gravitational dance, which currently governs so much of our world, would transform into an intricate, perhaps even chaotic cosmic ballet. Would Earth be a paradise bathed in double moonlight, or a planet racked by unimaginable forces? Implications are staggering, affecting everything from the ocean's roar to the very evolution of every creature that crawls, swims, or flies. Forget what you think you know about our quiet blue marble. Today, we're diving deep into an alternate reality, a world where our home planet isn't just Earth, but Earth with two moons. Prepare to have your perceptions of lunar influence, planetary stability, and the very nature of life challenged as we explore this truly captivating what-if scenario. Our journey into this two-moon world begins with the fundamental question: how could Earth even acquire a second moon, and what would it look like? For a second moon to exist, it would likely need to be significantly smaller than our current moon to maintain a stable orbit. Or perhaps it could orbit at a very different distance or inclination. One possibility is the capture of an asteroid, similar to how Mars acquired its two small, irregularly shaped moons, Phobos and Deimos. These are believed to be captured asteroids rather than objects formed alongside Mars. Another scenario might involve Earth forming with two large moons, a much more complex and perhaps less stable formation process. However, for the sake of our thought experiment, let's imagine a second moon, say roughly 1/4 the diameter of our current moon, orbiting perhaps twice as far out, or even closer, in a resonant orbit. The stability of such a system is paramount. Two moons in orbit around a planet exert gravitational forces on each other, which can lead to complex interactions. For long timescales, these interactions could cause one moon to be ejected from orbit, or even crash into the Earth or the other moon. For a stable configuration, the moons would likely need to be in what's called an orbital resonance, where their orbital periods are simple integer ratios, e.g. one moon completing two orbits for every one orbit of the other. This kind of resonance is observed in the moons of Jupiter and Saturn, like the Galilean moons of Jupiter, Io, Europa, Ganymede, and Callisto, which maintain stable orbits due to their resonant relationship. Without such a delicate balance, the gravitational perturbations could lead to instability over millions of years. Now, let's delve into the most immediate and dramatic consequence of a second moon: the tides. Our current moon is the primary driver of Earth's ocean tides. Its gravitational pull creates bulges of water on both the side of Earth facing the moon and the side opposite the moon. The sun also influences tides, but to a lesser extent, contributing to what we call spring tides, when the sun, Earth, and moon are aligned, and neap tides when they are at right angles. With two moons, the tidal forces would become exponentially more complex, and in many scenarios, significantly more extreme. Imagine a scenario where both moons align with the Earth and the sun. The gravitational pull on our oceans would be immense, resulting in colossal spring tides that could dwarf anything we experience today. Coastal areas would face unprecedented inundation, with vast stretches of land being submerged twice daily, only to be exposed hours later. The sheer volume of water moving would generate powerful currents, potentially carving out new coastlines and reshaping continents over geological timescales. Conversely, when the moons were positioned to counteract each other's gravitational pull, the neap tides might be exceptionally low, revealing expansive mudflats and exposing marine life to harsh conditions. This extreme tidal range would not only affect the oceans, but also the solid Earth itself. The gravitational flexing, or solid Earth tides, would be amplified, potentially leading to increased seismic activity, more frequent earthquakes, and even volcanic eruptions. The constant stress on Earth's crust could make our planet geologically far more active and unstable. Beyond the raw power of the tides, a second moon would profoundly alter Earth's environment and climate. The increased tidal friction would act as a powerful brake on Earth's rotation, potentially slowing its spin far more rapidly than our single moon does. This would mean shorter days in the distant past and even longer days in the future, if the moons could remain stable. A slower rotation rate could lead to more extreme weather patterns, with longer periods of sunlight and darkness, influencing atmospheric circulation and oceanic currents. Imagine prolonged periods of intense heat followed by extended, frigid nights. The night sky itself would be a spectacle. With two moons, we would witness a mesmerizing display of lunar phases, with one waxing while the other waned, and the potential for double eclipses, where one moon passes in front of or behind the other, or both moons simultaneously eclipse the sun or are eclipsed by Earth. This increased nighttime illumination could significantly impact nocturnal animals, potentially leading to evolutionary adaptations for species that rely on darkness for hunting or protection. For early hominids, a brighter night might have offered different evolutionary pressures, perhaps enabling extended foraging or travel after sunset, but also potentially exposing them to predators more easily. The sheer visual impact would undoubtedly shape human culture, mythology, and art in ways we can only begin to imagine. The most fascinating implications of a two-moon system lie in its impact on the evolution and development of life on Earth. Highly dynamic intertidal zones, constantly scoured by extreme tides, would become unique evolutionary crucibles. Organisms living there would need extraordinary adaptations to cope with daily desiccation, crushing waves, and rapid changes in salinity and temperature. This could lead to a burst of biodiversity in these challenging environments, as species evolve specialized mechanisms for survival. For example, some organisms might develop stronger anchoring capabilities, while others might become more mobile to escape the most violent tidal surges. However, the sheer unpredictability and harshness could also limit biodiversity in some areas. The increased tidal mixing of ocean waters could also play a role in nutrient distribution, potentially leading to richer marine ecosystems in some regions, but also more turbulent and less predictable conditions. Very origin of life, or abiogenesis, which some theories suggest occurred in tidal pools, could have been influenced dramatically by such extreme conditions. More frequent wetting and drying cycles, combined with increased energy from tidal friction, might have provided a different chemical environment for the complex molecules of life to first emerge. Furthermore, the rhythmic cycles of two moons would have influenced biological clocks and reproductive cycles of countless species, from marine creatures spawning with the tides to terrestrial animals responding to lunar light cycles. Our own internal rhythms might be subtly different, tuned to a more complex celestial dance. Finally, consider the profound impact on human civilization and culture. Our calendars, steeped in the cycles of our single moon, would be drastically different, perhaps incorporating the rhythms of two celestial bodies, leading to more complex timekeeping. Navigation by the stars and moons would be a more intricate affair, demanding a deeper understanding of celestial mechanics. Mythology would undoubtedly be richer, populated by tales of two lunar deities, perhaps siblings or rivals, each influencing different aspects of human life and the natural world. The night sky, an ever-present canvas, would inspire artists and poets in entirely new ways. With its dual